Good morning, everyone. My name is Ezra, and today I will present the progress of my undergraduate thesis with the title of Isolation and Identification of Antibacterial Compound against E. coli and SRUs from marine swans, Cystospongia, collected from Gili Tapang, Probolinggo, East Java. This research is conducted under the supervision of Respati Trisasono. The background. Indonesia is part of the Coral Triangle and one of the world's richest marine biodiversity region. Marine swans are known to produce a wide variety of secondary metabolites with biological activity, for example, like antimicrobial, anti-cancer, and cytotoxic effects. Among these organisms, Cystospongia species has attracted attention due to its potential as a source of bioactive compound. However, the chemical constitution and biological activities of specimens collected from Kilitapang have not been extensively studied, and therefore this research aims to explore its antibacterial potential through bioassay guided isolation approach. And this exploration of new antibacterial compound is very important because various infection diseases are developing to resist more of the antibiotics available in the market, with the estimates of 4.71 million deaths associated with MMR or antimicrobial resistance, including 1.14 million deaths directly attributed to MMR. First objective, first is to isolate, fractionate, and identify the antibacterial active compound from the extract of marine sponge collected from Kilitapang and using a bioassay guided approach. And second is to evaluate the antibacterial activity of the sponge extract and its fraction against E. coli and SRUs. With this benefit, first, to provide scientific information regarding the antibacterial potential of bioactive compound derived from the sponge against E. coli and SRUs. And second is to contribute the discovery of new natural antibacterial compound from marine resources that may serve as potential candidates for future drug development. And this study follow a bioassay isolation strategy. And first, the sponge is collected and then it's identified. Next, it's extracted with the ethyl acetate solvent. And if there was no ethyl acetate fractions, we'll try again and until it does. And if it yes, we'll begin the initial antimicrobial activity screening and see if it's active. And if it's not, then we'll see its general toxicity activity. And if it's not active, so maybe the sponge that we are having is not biologically active. But if it's active, as activity, we'll begin the fractionation, and then we'll test each of the fraction with the antimicrobial test, and then after that we identified the active compound with the liquid chromatography, high resolution mass spectrometry, and then that's it. And then we are continue for the literature review, and the sea swans are among the oldest animals, lacking true tissue and organ, and survive by filter feeding, throwing water through their body to trap food. And then some swans, such as Haliguna, Petrusia, and Discodenia, are known to produce bioactive compound, including anti-cancer and anti-inflammatory molecule. Therefore, a bioassay guided isolation from Cystospongia holds promise for discovering a new compound with pharmaceutical potential. And Cystospongia area, collected from the coastal water of Kilitapang, Probolinggo, showed a massive and compact morphology, typically a barrel shape with a hard and firm consistency, and the surface is generally rough with a large osculum at the top, and the color range from brown to reddish brown, and found in the Indo-Pacific coral reef ecosystem, including Indonesia, Papua New Guinea, and other tropical marine region, maybe like Philippines, Malaysia, Brunei, or Thailand, and maybe even Vietnam. With the taxonomy of kingdom Animalia, phylum Porifera, the class is Demas, the order is Haplosclerida, am I pronouncing it right? And its family is Petrosidae, and the genus is Cystospongia, the species is Testudinalia. And this is the example of the identified compound. We got pentadecanoic acid, it is classified as fatty acid, and testosterone, and its class is sterol, and it's found in Vietnam, and the first compound is found at the Malaysian archipelago. And then there's the antimicrobial test that I'm going to be using with this diffusion. Kirby Boyer is a simple and widely used technique to evaluate antimicrobial activity. It involves placing antibiotic impregnant discs on agar inoculated with microorganisms, allowing the compound to diffuse and form a concentration gradient. The effectiveness of the antimicrobial agent is indicated by the formation of clear inhibition clear zone around the disc. And if it's more than 20 millimeter, its inhibitory power is good, and the bacteria is susceptible, and then if it's less than 14 millimeter, is the bacteria resistant to the compound. And for the hypothesis is that Testospongia testudinaria is a marine sponge known to produce a wide range of bioactive secondary metabolites, including sterol, fatty acid, and alkaloid with significant biological activity. Several studies reported that compound isolated from this species exhibit antibacterial activity against both gram-positive and gram-negative bacteria, including SRUs and E. coli. Additionally, environmental factors such as geographic location can influence the composition and bioactivity of the secondary metabolites in the sponge. And antibacterial activity is commonly evaluated using the distribution method, where bioactive compound diffuse into agar media and inoculated with bacteria, forming an infiltration zone. This method is widely used as a simple and reliable preliminary screening technique to assess antibacterial potential. So the hypothesis is if the ethyl acetate extract of the Cystospongia collected from Kilitapang contains antibacterial compound, then the extract will inhibit the growth of the SRUs and E. coli in the disc. So the second rationale is the ethyl acetate semicolloid solvent is widely used in marine natural product extraction due to its ability to isolate diverse bioactive secondary metabolites such as alkaloids, sterol, and fatty acid derivative. Previous study has shown that ethyl acetate extract from marine swans exhibits significant antibacterial activity against pathogenic bacteria, including SRUs and E. coli, with strong inhibition observed in these diffusion assays. This effectiveness is attributed to the solvent capacity to concentrate semipolar antibacterial compound, making it suitable for subsequent fractionation and compound identification. Therefore, ethyl acetate extraction is considered an appropriate approach for isolating antibacterial metabolites from Cystospongia testudinaria. So the hypothesis is if the ethyl acetate fraction of the Cystospongia extract from Probolinggo is fractionated and analyzed, then the fraction showing the strongest antibacterial activity against the bacteria will be identified by the LG-HRMS and is expected to contain semipolar secondary metabolites such as alkaloids, sterol, or maybe fatty acid derivative, which is commonly associated with antibacterial activity. And the method is first the sponge harvesting and identification. The sponge is collected from the coral reef area around Kilitapang, and then it's identified by the animal systematic laboratory in the Faculty of Biology in Gajah University. And then the isolation of the Spongia compound is the sample is measured with methanol and chromethane to separate the water and salt, and then the result are filtered, and then the filter is separated, and then we thicken dichloromethane phase, and then the thick extract was extracted with ethyl acetate and distilled water to separate the polar and the semi-polar to non-polar compound, and then the ethyl acetate phase is evaporated. And then we screen for the antimicrobial activity with the distribution, and first we suspend the bacteria to bacteria, SRUs, and E. coli, and then we strip the whole surface of agar, and then we dip the dish in the sample of 3000 ppm, and the control dish is first is the positive control, the ampicillin, and the negative control is the MSO, and then the dish was placed in half lid open, then incubated at 37 Celsius degree, and then the zone inhibition is observed and then calculated. If the initial antibacterial activity is doesn't show any activity, we go to the general toxicity, which is the brine shrimp lethality test. First we breed the Artemia salina larvae for 2 days, and then the 10 larvae were put to each of the micro well, each hole, and then we extract of the sample were uh, concentrated with various concentration with 2000 to 500 microgram per milliliter or ppm, and then we add each of the variation into the hole containing larvae, and then the dead larvae were counted and analyzed for LC50 with proper value. And then after that, if it show any activity, we go to the next step, which is the fractionation. We're using color chromatography, and then the eluate is collected in the vial, and then the combining eluate based on we combine the fraction based on pattern similarity in TLC, and then the eluate of its combined fraction was evaporated at room temperature, and then the several fraction with the heavy mass were retested for toxicity, and then we test each of the fraction or the one who has the most weight to the antimicrobial test, which is the same as last time's that, but with more variation, which variation contain each of the sample of each fraction. And then we got the LC-SRMS, which is the liquid chromatography high resolution mass spectrometry, to identify the fraction with the highest toxicity activity. And then this is my progress. First, we already acquired the sponge in the Probolinggo, Gili Island, and then we extract it and got 0.42 gram or with a yield of 0.043%. And then we identified the result, identified the sponge species. It's revealed to be Cystospongia estutinaria, and then we test it with the antimicrobial or the distribution test. And as you can see, most of the not most, all of it quite resistant to the bacteria. So yeah, it is not a good result. So we are going to test it with the general toxicity test, and it show that the LC50 value is 234.88 microgram per milliliter, and so it's categorized as toxic. And the next step is we are going to fractionate, and I'm already done the fractionation, but we haven't tested the activity of its fraction, and we are still waiting for the uh, fraction to the solvent to evaporate. So it's going to take a week, I think, to finish the fractionation. And then after that, after we test the activity of its fraction and determine which is the most toxic, and then we are going to identify the compound with the LC-SRMS. And then yeah, we done it. Thank you for listening. And is there any question? I guess not now, but yeah.